The voice is clear. Comment fast. Voice clear. No, voice. Okay, fully clear. Okay. I require today full board because last time question, see, you remember, I first thought of recording one more class and uploading. Then I decided because I told so many principles there about taking section and constants of integration and boundary conditions, all told there. So just because of some substitution mistake, I told you, not technical, simplification or substituting. See, what happened is, one w here, w x into x square by 2, or somewhere here I think, or here, somewhere there was a mistake. See, 6, some mistake means number mistake. Because of that one answer did not tally. Then finally it tallied. But still I am not happy about it. So I wrote the full question once again. So make a note. Last time question you study. For principles all steps I told you, take origin, take a section, then boundary conditions, integrate twice, that all you see there. But when you write the values, refer this question. See, question is here. You can see the question here. I wrote everything. A simply supported beam of span L is loaded by an UDL of intensity W per unit length over the entire length. See, full length. Find maximum slope and maximum deflection. Also find slope and deflection at L by 3 from left end and at L by 4 from right end. Actually, for these two also, in the end, because I got irritated, because of what? Your also contribution is there. You told actually there was a problem of a net problem. Your comments were not coming. Actually, I saw later. You commented that it is not 6, etc. You commented. But it did not reach me. So, therefore, what you do is, even this also I don't know. Because when you get irritated or somewhat, when you lose the interest, because you are in the mind, what happens is feeling comes. Simple question answer, some trouble came. Then some calculation mistake. So therefore I decided, you see steps all there, but make a fair copy from here. Clear? Okay, start. See, I'll finish everything fast now. A and B, calculation of support reactions. This all told. Due to symmetry, VA upward equal to VB upward equal to total downward load on the beam divided by 2. W into L is the total load divided by 2. Over. Then take origin. You can take left hand origin or right hand origin. But you should take always extreme end origin. These all I will give steps for you when I start Macaulay's method. At that time I will tell you, write everything. Because this method, we are actually very early, we are quitting. We are telling goodbye. You will tell, hey, double integration method, you got lot of problems. Your method only will be modified, but this is Macaulay's method. We will do more question on Macaulay's. So this is only to understand. So, taking left hand A as origin, consider a section XX at X from A. Where means anywhere. See, it can be here, it can be here, it can be anywhere, because between A and B, there is no change of BM equation. If a point load is there, it will come next. Okay, start. BM at XX plus sagging positive. And remember, see, note, we are taking left hand origin. I told you, when you take left hand origin, theta is, see, I told crude method for you. Put the pen here. Deflection is always upward positive. So, move up. Slope is, this is a crude method, anti-clockwise positive. Deflection and bending moment, always deflection upward positive, irrespective of left origin or right origin. So remember, left origin means slope anti-clockwise positive, right origin means slope clockwise positive. Whichever origin you take, deflection is upward positive and bending moment is sagging positive. Over. BM here, WL by 2 into X positive minus W into X is the total load into X by 2. Okay. Now, simplify. WX square by 2 will become equate to EI d square Y by dx square. Standard. Why? because we know that ei d square y by dx square equal to mx. Okay, now integrate. When you integrate, write this one left side. Ei dy by dx, that is slope anti-clockwise at any point x equal to c1, a constant, plus wl by 2 into x becomes x square by 2 minus w into x square becomes x cube by 3. Already 2 is there, it will become 6. I never write what? See, one more thing. I can put this as WL into x square by 4. No, I am used to it. X square by 2 always in this method. X square by 2 comes, x cube by 6 comes, x power 4 by 24 comes, x power 5 by 120 will come. Therefore, if anything is there, put outside. Okay. Once again integrate. C1 becomes C1x. See, the blue color is constant. X is variable plus C2. WL by 2 into x cube by 6. W into x power 4 by 4 into 6, 24. Deflection equation. To get constants of integration C1, C2, use boundary conditions. Make a note. Boundary condition means, see, we want substitute in these two equations. We want zero slope or zero deflection. Boundary means zero values are required, others not useful. So, simply support beam, see, will bend this way. This is symmetrical loaded. So, whatever is the loading, see, this is called deflection. At A, deflection 0, at B, deflection 0, and also because of perfect symmetry, see, because of perfect symmetry, deflection at C will be maximum. See, deflection at C is maximum. See, I written here, due to symmetry, Y max will be at center. This you cannot apply for unsymmetrical case. And where Y is maximum, draw a tangent, slope equal to 0. Or mathematics, see, for Y to be maximum, dy by dx should be equal to 0, over. Now, we have three boundary conditions, Ya 0, Yb 0, and theta c 0. Or, if I start from here, sorry, note, we have three boundary conditions. Start, Ya 0, then center, theta c 0. But theta c 0 is only due to symmetry. These are always correct. Symmetry or not, deflection at A0, deflection at B0, deflection at center will be 0, only for symmetry. You can make a note here. See, this is only due to symmetry. Due to symmetry. Okay. Now, but only two unknowns, C1 and C2. Suddenly, class, important logical question asked. Answer it. I will ask the question once again for those who think they know mathematics or basic concept very well. Answer the question. Beautiful answer is there. See, I told long back, if number of unknowns are more, it becomes indeterminate. Not here, in analysis. If number of unknowns are equal to condition, determinate. If number of unknowns are less than what? If number of unknowns are, if the number of equations, suppose if shortage is there, it is called indeterminate. If correctly equal, determinate. If excess is there, their structure is unstable. I told you, if two unknowns are there, there should be only two equations. Third equation is not possible. Not possible. But here, two unknowns, which one? C1, C2. Three conditions. Logical question. Therefore, as per my statement, it is nonsense. It is not nonsense. I will tell you the hint for you. You can use either, start from here, deflection at A0, go to center, slope at C0, over. Don't use deflection at B0. Because if you use Ya0, theta 0, it is as good as using Yb0. Yb0 is not extra equation, it will be automatically satisfied. Or, do one thing, don't use the slope. Use Ya0, Yb0. If you use Ya0, Yb0, that's what you are doing in all Macaulay's method. Okay. Then it is as good as using theta c0. I want logical answer. Come on, give the answer. People who think they know basic concept very well, now is the time to give the answer. Let me see how many will answer it. Answer is so simple. Okay, start. Option 1. Consider, I will use one thing. I will use YA0, deflection at A0, slope at C0. YA0 and theta 0. Start. YA0. Y becomes 0 because X is from here. For X equal to 0. Substitute in deflection equation. 0 equal to 0, C2, 0, 0. C2 becomes 0. Then, theta C equal to 0. That is, theta means dy by dx. For X equal to L by 2. Substitute in the slope equation. 0 equal to C1 plus WL by 2 into what? L square, L by 2 square by 2 minus W into L by 2 cube by 6. Simplify. C1 will come minus WL cube by 24. Last time by mistake I wrote 16. That is for point load. Something happened there. Now corrected. Over. Or option 2. Do one thing. Don't use theta C0. YA0, YB0. Use YA0 and YB0. See, I substituted. Then also your C1 will come same. This we got last time. Okay, start. Note in class what? I forgot now. Note in class. Yes. One note. Now, if you use, see, here you used YA0 and YB0. If you substitute X equal to L by 2, theta C will come 0. Or here. Here we used, first time we used YA0, theta C 0. Put X equal to L, my guarantee YB also will come 0. Therefore, even though it is 3 conditions, it is actually only 2 conditions. When you use any 2 of them, other one is automatically satisfied. It is not a new condition. Like see, 4x plus 10y equal to 20. If you write by chance 8x plus 12y equal to minus 8, correct? Suppose you multiply by 2 here, instead of 3, 4 becomes 12x plus 30y equal to 60 means you cannot tell 3 equation. It is nothing but this equation only. Then you can do one thing. You can create any number of equations. So therefore, remember, even though there are 3 conditions, 2 of them satisfied means other has to satisfy. It is not a 3 unknown. See, using these 3 unknown conditions, you cannot find third unknown. No, unknowns are only C1, C2, all over. Now start. Done that. To find maximum slope and maximum deflection. See, simply support beam will bend like this. See, maximum slope will be at support. Slope means turning. So theta max equal to theta A or theta B. Whichever is higher. Class means, see, this is irrespective of symmetry or unsymmetry. Why? It's either maximum at A or at B. But here, due to symmetry, theta A equal to theta B. Therefore, find any one of them. Say theta A. Easy. Why? Substitute x equal to 0. See here. EI theta A in anti-clockwise equal to C1. That's all. 0, 0. Your theta A comes WL cube by minus WL cube by 24. EI theta A. Or theta A equal to WL cube by 24 EI. Anti-clockwise positive. Negative came clockwise. Correct. See. Slope is clockwise. Here I use double arrow mark. Why? Sign comes later. Okay, now you need not find theta B. Due to symmetry, theta B is WL cube by 24 EI only anti-clockwise. Remember, class, see, not fully visible there. Rotation, I write once again. Make a note here. Class, rotational symmetry is always opposite. Means, if symmetry, if anything is anti-clockwise, for you it is clockwise. If anything is clockwise here, symmetry means it is anti-clockwise here. Remember, see, rotational symmetry is always opposite. If a fixed moment later is anti-clockwise here, due to symmetry, other side will be clockwise. If both are clockwise, it is not symmetry. Over. Or, just for curiosity, do one thing. Don't use symmetry. To find theta B, put x equal to L. in slope equation. See, I got answer plus WL cube by 24 plus Y anti-clockwise positive. Yes, therefore theta B is WL cube by 24 EI. So far, fully clear? Past, tell me. So far, fully clear? Now what? You should see in the laptop. You should see in the laptop. Mobile difficult. See in the laptop always. Others can see properly. Others can see properly. Yes, I can also see here. Others can see properly in the laptop. First. See in the laptop. Or if I turn, who told? Very much visible. See, if I turn mobile also, very clearly visible. You are going to use lesser, what you call data, I think. That's why problem. If you use 480 and use full screen, it will come correctly. This is what I am telling all these days. Okay. Now, start further. See, now conclusion, I will do one thing now. I will write here remaining portion. See, further continuation, I will write here. Little rubbing required. Little later, I will rub the full board. Okay, on me. Now see, we got theta A and we got theta B. Start. Now, therefore, continue. Therefore, theta max, if you want write, that is maximum slope for the beam equal to WL cube by 24 EI. Tell where? That much radians where? At supports. At supports means both A and B. Okay. Theta max over. Now, to get Y max, see, due to symmetry, Y max will be at center. Say C. I mark center here, see. I already marked center here, C. So center means from here to here, see, this will be L by 2. Okay, start. Therefore, find YC. Find Y at C, center. For which substitute X equal to, now I am not using red color now, I use black color only. X equal to L by 2 in deflection equation. Start. Therefore, EI YC upward positive equal to C1 into X minus WL cube by 24 into L by 2 plus C2 is already 0, then plus WL by 2 into X cube by 6, L by 2 cube divided by 6 minus W into L by 2 power 4 by 24 or equal to, see, WL cube into L, WL power 4, L into L cube, L power 4, WL power 4 outside if you take, it will come, take calculator, it will come 24 into 2 minus 1 by 48 plus 2 into 2 is 8, 8 into 2 is 16 plus 1 by 96 minus 1 by 2 power 4 is 16. 16 into 24. 1 by 384. Or if you calculate, it will come WL power 4 into, see, minus 1 by 48 plus 1 by 96 minus 1 by 384 comes to minus 5 by 384. 5 by 384. Okay, write it here. Therefore, deflection at C equal to, no minus now, 5 by 384 WL power 4 by EI. That much you took upward positive, negative came, that much downwards. Over. That itself is Y maximum. Over. Therefore, present answer. Therefore, maximum deflection for the beam, deflection equal to 5 by 384 WL power 4 by EI downward at center. This will complete the maximum slope and maximum deflection. Okay, now 2 extra points are there. Last time what happened is, it gave trouble. I will do one thing now. I will try here now. Those 2 extra, I will try here now. Okay, start. Now, see, actually standard is over. Now, to find slope and deflection, to save the time, theta and y, at those two given points, where say P1 and P2, my name. See the question there. This is A, this is B. X is always from here, remember. This is the origin. One of the point is L by 3 from left hand. So mark here, P1 here, at L by 3 from left hand. P2 point is here, at L by 4 from right hand. See, you can write here. P1 is at L by 3 from A as per question. P2 is at L by 4 from B. Okay, start. First, consider P1. Consider the point P1. Make a note. Irrespective of you want slope at P1 or deflection at P1, value of x for P1 equal to L by 3. Okay, start. First, to get slope at P1, substitute x equal to L by 3 in slope equation. Next time onwards, these all I am not doing, because why? Anybody can do it. Start. Slope equation. EI slope theta at P1 anti-clockwise positive equal to, see, C1 minus WL cube by 24 plus WL by 2 into x square by 2 is L by 3 square divided by 2 minus W into x cube by 6. L by 3 cube divided by 6 or equal to WL cube, WL into L square, WL cube. You can push WL cube outside, it will come. Now, tell the answer at least. Minus 1 by 24 plus 1 by 4 into 1 by 8 minus 1 by 6 into 1 by 27. If wrong, tell me. Minus 43 by 2592. Is it correct? Tell the answer. Fast. Is it correct or not? Question should be perfectly over. Is it correct? Fast, comment it. Minus 43 by 2592. Is the value correct? Fast. Is the value correct? See, this if it is wrong, I am not responsible. Maximum slope, maximum deflections are standard value. I know it. Maximum slope, WL cube by 24 EI, maximum deflection, 5 by 384, WL power 4 by EI. These all who knows? So, this is a extra question. You are not commenting. See? You have to answer. Correct. Okay. Now present the answer. Therefore, slope at the point P1 equal to, no minus sign, 43 by 2592 times WL cube by EI, anti-clockwise positive, negative came, that much clockwise. Over. Theta P1 is over. Next. I'll write here now. After theta P1, see, use the space here to save the time. Little later, I reduce the board size. Here because only purpose is to see that everything is visible for you. Okay, now, to get deflection at P1, what you do? Substitute x equal to L by 3 in deflection equation. Start. EI deflection equation. Y at the point P1 equal to C1 into x. Where is C1? Minus WL cube by 24 into L by 3 plus C2 is already 0. Then minus plus WL by 2 into x cube by 6. L by 3 cube divided by 6 minus W into x power 4 by 24. L by 3 power 4 by 24 or equal to L cube into L power 4. W L power 4 outside if you take, it is minus 1 by 24 plus 3 9 9 18 18 108 1 by 108 ಕರೆಕ್ಟಾ 3 3 9 3 27 27 27 54 ಅಲ್ಲಲ್ಲ ನಾಟ್ 108 9 18 3 9 9 3 27 27 54 54 into 6 see it's ABCD Kannada only I can calculate 54 into 6 is 324 correct 1 by 2 into 1 by 8 1 by 8 1 by 27 divided by 6 yes 1 by 324 minus 1 by 3 cube 3 power 4 is 81 1 by 81 divided by 24 is it is giving 1 by 1944 if it is wrong or equal to WL power 4 into minus 1 by 72 plus 1 by 324 minus 1 by 1944 comes to minus 11 by 972. Tell me, is it correct? Fast. Is it correct? Fast. Is it correct? Minus 11 by 972. Correct? Fast comment. Minus 11 by 972. Is it correct? Correct. Okay. Therefore, deflection at P1 equal to 11 by 972 WL power 4 by EI, that much downwards. Why? Negative came. Now, similarly, to find theta at P2 and y at P2, what you do? Substitute x equal to, see, your P2 point is where? P2, see correctly now. This is the beam. Origin is A. A is the origin. Your P2 is here. This is L by 4. But you should substitute from origin. Your x will be equal to L minus L by 4 equal to 3L by 4. X equal to 3L by 4. First, in slope equation and get theta P2 equal to. And in deflection equation, get yp2. I will directly give the answer to you. Check the answer. I will give the answer for you. Slope 1 by 24 plus 1 by minus 1 by 24 plus 1 by 2 into 1 by 16 divided by 2 minus 1 by 6 into 1 by 64. Is the slope answer 11 by 384 WL cube by EI anti-clockwise. Plus will come. Correct answer, tell me. Is the answer correct? Little hot today, I don't know why. Suddenly very hot today. I will not put the fan answer because nowadays, because of low temperature, every full day will be very cold. But suddenly it became hot today. Is that answer correct? Is that answer correct? 11 by 384. Did you get it? Otherwise, get later. Okay, I will go further. If it is wrong, correct it. And deflection will come. Minus 1 by 24 into 1 by 4 plus 1 by 2 into 1 by 2 into x cube 1 by 4 1 by 64 divided by 6 minus 1 by 24 into 1 by 256. 19 by 2048 WL power 4 by EI down will come. You check it. Is the answer correct? Okay. Now this question is over. I will go to next question. Full board I will rub. Now remember, you will understand why. See, if full span is UDL, between the two ends, there is only one section, between the two supports. Wherever you take section, in terms of x, mx will come same. It will have single variation. Means what? There is no change in between. That's why if full span is UDL, double integration method and Macaulay's method both are same. Later, Macaulay's method, full span UDL I will not do. Why? It is same, no change. But remember, when point load comes, or if the UDL is not full span, or you can remember between the ends, in between, if more standard, if any standard point, either one or more there, in between the two supports, if standard points are there, like UDL ending or point load or double point load, etc., then double integration method becomes horrible. It becomes horrible then. But I will show you why horrible. But Macaulay's method is very fast, because maybe double integration method, you have take multiple sections then. For each variation, you have take multiple sections. And then it will be very lengthy procedure. But Macaulay's method, any number of variation in between, single equation. That I will tell you, after double integration, we go for a point load. See. Now, be careful. I'll take one question. This is homework for you. You can do yourself only. Homework. Homework. A simply supported beam of span L is loaded by a central concentrated load of magnitude W. Okay. Find maximum slope and maximum deflection. Maximum slope and maximum deflection. Then also find is not there, sufficient. See, now start solution solve by double integration method. Okay, first step, put the beam, central load W. This is A, this is B. This is L by 2, total is L. This is VA, this is VB. Here also, this is C. Due to symmetry, your VA equal to VB equal to W by 2. I will not explain further. Waste of time. Okay. Why? Total load by 2. Over. Now, take A. Now, make a note. I am going to dictate. You write everything after the class going through the YouTube video. Okay, actually it's not called video. YouTube class. Okay, see. Now, last time question, it was full UDL. A, B. There is no standard point in between. Therefore, you have to take a section XX between A and B. So I use red color. 1 minute. 1 minute. No, I want red color only for this one. Yes, in the right time I won't get red color. I got it. Last time, if I take A origin, take a section here. See. But here, right here. But here, see. If I take, see now here, for this is for last time question. But right. But here, see. This is A, this is B. This is point load W. If I take A origin, then ABC, reaction equal to W by 2, reaction equal to VB equal to W by 2. If I take a section XX here at X from here, then your BM there equal to plus what? W by 2 into X. Over. But this is valid for A to C or 0 to L by 2. Over. Now, this equation you cannot use for a section here. Of course, by changing origin valid, that is something else. Now, see, same question. Suppose, see, this equation Suppose you have A here, B here, A origin. Take a load W here. This is W by 2, this is W by 2. Okay. This is A, B, C. If you take a section XX here, at X from A, then this is L by 2, this is L. Your BM, bending moment here, at XX, will be W by 2 into X plus W by 2 into X minus W into this distance is X minus L by 2. Because see, if you draw bending moment diagram from A to C, it will keep on increasing. It will become WL by 4 here. Then it will start decreasing. Now, if I write here, now you have to write, if I use this equation, I'll do one thing now. This I will call star equation. This I will call double star equation. You write, if I use star equation, beyond C, it will give bending moment diagram like this. Why? W by 2 into X. When you come here, you put this one X. It is wrong. Why? The moment you cross the point C, BM equation will change. The previous equation, what equation or expression for BM you wrote for AC is not valid for CB portion. Is it fully clear? You write, it is not, see, because if you use by mistake the same equation, it will give the diagram like this. It will keep on increasing. Clear or not? First, that equation is not valid because once you go beyond C, minus that W will come. First. Clear or not? Clear. Therefore, single section, you cannot solve the question. Therefore, finally, for AC portion, we need a section XX, we need one section XX, and also for CB portion, we need another section XX. That's okay, but problem will come for constants of integration. That all I will show you for you. Therefore, what happens now is problem comes. But right here. But fortunately, see, even though there is a point load, no problem. For this question, we can take only one section. You write, because you take a section between A and C and solve. But remember, that section is not valid beyond C. Then someone will tell, how to find slope and deflection that side? No problem. Because fortunately, because this is symmetrical case. Because that is symmetrical case, you can take a section XX here, analyze only from A to C. Yes, two boundary conditions are there. Deflection at A0, slope at C0. Deflection at B you cannot use. Why? To get deflection at B, you have to put X equal to L. X equal to L you cannot substitute in this equation. This section is valid only from 0 to L by 2. But no problem. You can use deflection at A and symmetry is there, slope at C0. Using that you can find C1, C2, and then you can find maximum slope, maximum deflection. Suppose you want somewhere slope at B equal to slope at A in opposite direction. Suppose you want to find slope and deflection here. You find, suppose somewhere distance, say 1 meter from here. You find at 1 meter from here. You find 1 meter from here. Same answer there. But deflection same direction, slope opposite. Therefore, even though discontinuity is there, fortunately this question we can easily solve by double integration method. Therefore, I will briefly give question and stop. Clear now? This question you escaped because symmetry is helping you. Symmetry is helping you. The symmetry is helping you. Timed out. Timed out. Who timed out? 1 minute. I don't know what is happening. 300 seconds. I think it touched somewhere. 1 minute, 1 minute. Live chat. Just I see now. Hi. Who timed out first of all? Put user in timeout. Put user in timeout. Read user in timeout. I don't know. Mr. Suresh SN, can you see correctly? Something happened. Moderator all it came. I don't know what is happening. Why don't these people keep quiet? And because I put it in the pocket, I should next time I should put it here. Mr. Suresh, can you hear? Because it is coming, you are timed out. Can you hear? If you can hear, no problem. Some next time onwards, I won't put in the pocket. Can you hear? You can answer in the WhatsApp. If you are not able to comment, you can answer in the WhatsApp. Can you hear? Because I don't want to not to hear. Suresh SN was timed out by KSN. I never did anything. What is that timed out? Who timed out first of all? Deleted, something came. I don't know what is happening. Hi. Feel like throwing this outside. I never, it touched, something happened there, it came. Some timed out. Can you hear? Answer in the WhatsApp. You can answer in the WhatsApp. Can you hear? Because you are regular. I don't want to deny you the class. Deleted. Oh, okay. No problem. If you are here, okay. Because I don't know. Next time, I will not put in the pocket. Okay, now, start. Briefly solve and I will give the answer for you. Later, remember, same question we are solving by Macaulay's method. Solution. Take A as origin and consider section XX between A and C at X from A. Okay, I will put a sketch here and then give for you. See, this reaction VA equal to W by 2. This reaction VB equal to W by 2. This is a point load here, that is W. This is A, that is the origin here. This is center, this is B. Remember now, your X will go this way. Your section is here. This is X and this is L by 2. Remember now, make a note. This cannot be used beyond C or this equation for XX, see, or I'll write here now, bending moment at XX, that is called MX, sagging positive equal to plus W by 2 into X. That's all. Remember, valid only between A and C, that is X from 0 to L by 2. Beyond L by 2, we cannot use it. We cannot use this. Okay. But no problem. Tell me, why no problem? See, first, equal to EI d square y by dx square. Start. First I will solve. First, integrate. You get EI dy by dx, that is theta x anticlockwise equal to C1 plus w by 2 into x square by 2. Slope equation for a to c, that is 0 to L by 2. And integrate once again ei yx upward equal to c1x plus c2 plus w by 2 into x cube by 6 deflection equation only for a to c, that is 0 to L by 2. Okay, now to get c1 and c2, use boundary conditions. That is, see, the beam is this way, this central load here, beam will bend this way. At A origin, x is this way. Here, deflection at A equal to 0 and deflection at C is maximum because of symmetry. Therefore, this is C. Slope at C, theta C 0. B property we cannot use. Okay, start. YA 0. That is, Y becomes 0 for x equal to 0. You solve it. You will get C2 equal to 0. Then, theta C 0. So, theta equal to 0. Theta means dy by dx. For x equal to L by 2, you will get C1 equal to minus WL square by 16. My guarantee. Okay, over. Start. Now, happily find theta A, which is nothing but theta maximum, and deflection at C, which is y maximum. Here x equal to 0, here x equal to L by 2. Your answer, theta max will come WL square by 16 EI, and your y max will come WL cube by 48 EI. Can you try this one? Fast. No point in wasting time, because we will go to real concept now. That is, later remember, this method we are throwing out. We will tell it, hey, double integration method, you get out from here. You don't show your face once again to me. Why? Because we got a beautiful method where no confusion, which can be used for any number of standard points, single equation. So therefore, this method is completely going to be wiped out. It is only for understanding purpose. Okay, I put little link now. Start. Clear now? Now you can try yourself only. Yes means I will go to the next question. Yes, okay. Start. Now come to the real question. That is the question where or which will tell you don't use double integration method now onwards. That's all. This question will tell you horrible method. Actually, not horrible. Very, very inconvenient. Unnecessary, become time waste. So systematically I solve a question. See, I will put question here. See, question. A simply supported beam of span, I will take the span as 10 meter. I like 10 meter span. Is loaded by a concentrated load of anything 60 kilonewton at 4 meter from center, from left hand. 4 meter from left hand. That is not symmetrical. If it is symmetrical, you can solve. Now, here, find maximum slope. Find 1. Maximum slope. 2. Slope and deflection under the load. Next, 3. slope and deflection at center of the beam. Fourth one is the most important, maximum deflection. This question will take one full class tomorrow, because why? Then we will tell goodbye to this method, maximum deflection. This is the question. I am not giving EI because I do not want the question to be, or 1 minute now. Okay, take EI equal to, I will give directly EI in terms of required unit. Why? To save the time. Take EI equal to, where is the calculator? 1 minute now. 1152 by 20,000. Okay, EI equal to 40,000 kilonewton meter square. Next time I will give you that Newton millimeter all. Today directly I will give you. Okay, answer. Okay, now start. Solution by, solve by the horrible method, double integration method. Then you tell, you will realize the difficulty here, we will solve it. Then you will tell goodbye to this method. Okay, solution. This is the beam. This I will call A, this I will call B. See, span is 10 meter. Load is at 4 meter from here. Somewhere here, 4 meter. Eccentric load. How much load? 60 kilonewton. Okay. This is a beam. I will call the point as C. Now C is not center. C is the load point. Okay, start. Reaction VA, reaction VB. First, find reactions. You cannot write last time what? Total load by 2. Apply sigma m about A0. This all I will not explain. Take clockwise positive. Minus VB into 10 plus 60 into 4 equal to 0. Therefore, tell VB value first. VB in kilonewton. Plus will come. Sigma V0 upward positive. Plus VA plus VB minus 60 0. VB is already known. Therefore, get VA in kilonewton. Answer first. How much VB? How much VA? How much VB? How much VA? Fast. This much time for getting reaction. Oh yes, now it's okay because it came. You are removed from chatting from 300 seconds. I don't know how it came. I have not done it. How much? VBVA. See, if you don't give the answer, I have to stop the class. After writing this one, if you don't give VBV value, I have to stop the class then. See, remember, this is equilibrium, direction based. This is not bending moment. Anybody difficulty, go to my SFD BMD class, learn and come back. VB equal to 24 kilonewton, VA equal to 36 kilonewton. Okay, start. Now, VA, VB over. Now make a note. I will dictate, you write after the class over by going through YouTube class. Sections. If I take A origin and take a section here, it is valid from only 0 to 4. But A to C, then C1, C2 will come. But you cannot find C1, C2 because A to C, there is only one condition. What? Deflection at A equal to 0. Slope at C is not 0. It is unsymmetrical. Okay, then. So, 2 unknown you can't find. And second condition is deflection at B0. Beyond 4 meter, this equation cannot be used. So, you have to take one more section here. If you take one more section there, then tell me, one more mx equation will come, and again C1, C2 will come. Those C1, C2 will not be this C1, C2. Why? when the equation for bending moment changes, C1, C2 will change. Therefore, when I take A origin, if I take a section, if I consider AC, C1 and C2 will come. Now, for that AC equation, you cannot use for this portion. Now, but two unknowns are there. Only one condition. Which one? Deflection at A equal to 0. So, to use the deflection at B0, you take B origin and take a section between BC portion. Then C1, C2 will not come. Why? Because C1, C2 will come. That C1, C2 is not this C1, C2. Some other C1, C2. Say, I will tell C3 and C4. Oh, this is problematic. We want to get one extra equation which resulted in two more unknowns. See, here C1 is there. You have one more unknown, C2. To solve for C2, you want to use YB equal to 0. Oh, some will tell, yes, two conditions. But when you take a section there, these two over, two more unknown will come. Some other C1, C2. I can call C3, C4. Then how to solve, I will tell. After knowing all that one, high time, tell goodbye to double integration method, dim. Make it dim. Over. I will fully explain the concept. But remember, answer will come. I will tell now only. I will tell the answer now only. For me, answer is not a problem. I can solve this question in just 20 seconds. Why? I got no shortcut methods. So, the moment you give the answer, I can make out how much answer has to come. Okay, start. Now, systematically start. Sorry. Statement. I write here. Now, first statement required. Statements. To cover AC portion, consider A as origin and consider section XX between what? A and C, comma, at X from A. That is what? See here. See, correct, clear. This is A, take origin. There is a point load here, C. This is B, and red color I will use now. I will use red color now. Why? To make more clear. Again, same problem. This color problem, I don't know. Okay, see. I will take A origin and take a section here. X from here. This is 4 meter. 4 meter. Now, this section XX, this is your XX. Right here. This section XX is valid only for AC. That is for X varying from 0 to 4 meter. Over. 0 to 4. This is not writing properly. Use another color. Okay. 0 to 4. Okay. Now, what to do? Therefore, now see, to cover, when I want black color, both are coming red. There, next here, next see. Now, I'm not writing. Now, no, that pen only missing. It's there. It fell down. Okay. Now, to cover, this also not right. Sometimes it gives trouble means you don't know how much trouble it comes. Marathon trouble. Okay. To cover, which one? BC portion. I start from that side. BC or C to B, or I come from that side. BC portion. To cover BC, consider B as origin. And consider section. Some people have seen, they will tell section YY. No, section is XX only. Some will call this as X1, X1, that is X2, X2. No, call XX, some other XX. section XX only. Section XX where? Between B and C, comma, at X from B. This is X from A, X from B, as shown here. As shown here. This is A, this is a point load, this is C. You tell this side we are C, this is valid for this one. That's all. You cannot use for this one. Now, this is valid for this side. You cannot use here. This is the B origin. You make B origin, take a section XX here at X from here. Then this distance will be 6 meters. Now make a note. This XX is valid only for B to C. B to C. B to C. That is for X varying from here to here 0 to 6. 0 to 6. Somebody will start walking from A, reach C and stop. He will tell that's all. I am in charge of AC. Someone will start walking from B, measuring from B. He will walk up to C and tell I am in charge of BC. Tell me, fully clear? These all you write. Tell me, full clear or not? Full clear, this principle. This principle, fully clear. Okay, now I will start and bring to a stage. See now, draw a neat sketch. See correctly, when I continue tomorrow, this board I am not removing. This will be there tomorrow also. I will continue from here. Anybody coming tomorrow new, he will tell not clear. Not clear means go to previous class. Why you came today? See, start systematically. This is the beam. Okay, I'll put double line. Why? To make the beam perfect. This reaction VB equal to 24 kilonewton. This reaction VA equal to 36 kilonewton. There is a point load here of 60 kilonewton here, that is at C, and this is A, this is B. Now A is origin and B also origin. Now see, our beam has got two parts now. One section I am taking here, XX. I'll write X here, at X from here. And this X will vary from here to here 4 meters. And then I will take one more section here, XX. That is X from, see, this is X this way, X from here. See, I will put arrow mark here, this is up to 4. This is distance from here is 6 meters. This is valid for AC, that is valid for BC. Now, I already wrote statement. Yes. Statement over or not? Did I write the statement? Okay, I write the statement once again. Considering A as origin, I think I already told it. A as origin, and this I told you already, correct? Told or not? Already told. A as origin for AC 0 to 4 and B as origin for BC 0 to 6. Already told, I think, correct? Yes or no? I already wrote it. Why second time? You can write if you want. If you want, write here. Take A as origin, consider section XX at X from A and varies from 0 to 4. Then consider B as origin, take a section here at X from B 0 to 6. Okay, start. Now, correctly see now. First, see, for AC portion, very important, X from A, and it varies from 0 to 4 meters. Bending moment at XX, that is called MX equal to plus 36 into X. into x. Equate equal to ei d square y by dx square. Now integrate, right here, ei dy by dx. One minute now, x from a, make a note here, left hand origin, therefore theta is anti-clockwise positive. Remember, dy by dx, that is nothing but your theta at any point x in anti-clockwise equal to c1 plus 36 into x becomes x square by 2. This is the slope equation. And I will put the equation here. This is the slope equation. We will make the question perfect. Then integrate once again. Integrate. You get ei yx upward equal to c1 into x plus second constant called c2 plus 36 into x cube by 6 is a black color. X cube by 6. This is the deflection equation. Both these are valid for AC, x from A, and x limit is 0 to 4. Okay. Fully clear? Tell fast. Full clear or not? Fast. You tell clear, I will go to second section. If it is fully clear, fast. If fully clear, I will go to next part. After this question, we are not going to come once again to double integration method. This question, see, Macaulay's method, how fast you can solve. Okay, clear. Now, right here. Now, for tomorrow also I want full board for BC portion, see, your x is x from B, origin. See, this is x from A goes this way. This is x from B goes this way. Tell the answer. And remember, note, what is the note? Note, very important, right hand origin. I told you, right hand origin. Therefore, theta is now clockwise positive. This also I told you. When you take right hand origin, your theta is clockwise positive. I think visible. I think I should have put a little more ink to the pen. I forgot it. That's why paying penalty. Okay. That's again red color. See? Now I don't want red color. Wherever I touch, I am getting red color only. This I should be cleaning fast, little like clean required. Okay, I'll write once again. Because why? Neatly I require it. Okay. Now, for BC, what I wrote here? BC, your x is from B. X from B, that is x is this way now. X from B, it varies from 0 to 6 meter. Blue color, what to do? Sub color, 0 to 6 meter. Okay, then. Again I wrote over here, one note, warning. What is note? Right hand origin. This I told you last time, right hand origin. Therefore, theta is clockwise positive. Remember. So here, bending moment at xx, that is called mx. I'll change the color, blue. Okay. That is called mx. Again, remember, mx is always what? Sagging positive. Here also, sagging positive. Equal, look this side, plus 24 into x. 24 into x. Okay, now equate to ei d square y by dx square. Now, right, integrate. You get ei dy by dx, that is nothing but slope theta at any point x but this time in clockwise direction, equal to C1. Now you can't use C1. Why? Separate equation. See, there C1, C2. You can't use C1, C2. I will use C3 into X, C3 plus 24 into X becomes X square by 2. And this is going to be your slope equation. And once again integrate. You get again right here, again integrate. EI y at X upward positive equal to C3 into X, C3 into X plus one more constant C4. Why? When the equation changes, again C1, C2, but this is not that C1, C2. C4 plus 24 into X cube by 6. Yes. Now, this is called deflection equation. Remember, make a note, valid for B to C, for B to C. Here I wrote AC, valid for BC, and remember X from B, and varies from 0 to 6 meter. 0 to 6 meter. This much tell me, if this much is fully clear, I have to thoroughly explain the boundary condition and tell how you have to use the boundary condition and solve. If this much is clear, 10 minutes there, I won't start because right at 9 o'clock I got a commitment. And hurry means it will not be clear. No, you can do one thing. I will tell you hint for you. Tell me. If you want hint, you can try. What a hint? What to do? What a hint? What to do? If you want to tell a hint, I will tell you, but I will do systematically tomorrow. Because if I hurry, it will take at least 15-20 minutes now. If you want a hint, I will tell you. You can try how to get C1, C2 and C3, C4. Tell me fast. Or if you don't want, tell don't know. I will tell in the class. Or if you want to try something, at least sir, let us also try something. Use our knowledge. Tell me, I will give a hint for you. Fast. Tell me, do you want hint or no? Let it come by me on in the class. If you want a hint, tell me, I will tell a hint. Or you can tell, no, you only do it, we will follow later. Your choice. What do you want? What do you want? Hint and try, but this is fair copy. See, not answering. Do you want hint or I only will solve systematically. This I am not removing. Up to tomorrow it will be there. Give hint. Okay. See. Try now. This we can use only from 0 to 4. This I can use 0 to 6. Do one thing. Ya equal to 0. Y becomes 0 for x equal to 0. One condition. Your C2 will come 0. Then that's all. No more condition here. Then do one thing. Substitute x equal to 4 meter. Find slope at C and deflection at C. Okay. You get theta C and yc in terms of C2. In terms of C1. C2 becomes 0. In terms of C1, find slope and deflection at C. Now, change. Go this side. Substitute what? Y equal to 0 for x equal to 0. You get your C4 equal to 0. Then, that's all. Substitute x equal to 6 meter. Find once again slope at C and deflection at C by this side. Then unknowns are C2 0, C1 from here and C3 from here. To get those two, use the property. Whether you solve from this side or that side, slope at C is unique. Whatever theta C you got from this side should be theta C when you got from that side. One condition. Then, what deflection at C you got by put x equal to 4, same deflection has to come when you put x equal to 6 meter. So use those two, you get simultaneous equation in C1 and C3, solve, you get the unknowns. Then anything you want for AC, use the first equation from 0 to 4. Anything you want on BC, use second equation, you use 0 to 6. Suppose one more point load is there. Oh, you gone case, correct? Gone case then. That's why double integration method is not preferred when there is change of loading, or when there is a standard, further there are standard points in between the ends. It can be used for full UDL or central point load or end couple or cantilever with the tip load or full UDL. But why you want to waste time? That you can do by Macaulay also. So once this question is over, we will tell goodbye to double integration. Don't come back once again to me. Get out. It is actually we are using double integration only, proposed by Macaulay, where even if 100 point loads are there, only one equation. That is by adjusting the limit. So therefore, we will continue tomorrow. If possible, get C1 and C3. If you want, I will give the values now. If you are trying, tell me. I will give the answer. I can give it, no problem. For me, not a problem. If you want, tell me. I will give the answer. If you want, tell me. What I told, hint, you can try and use it. Do you want answer? At it. Tomorrow I will get it. My guarantee. Do you want answer? For me, not a problem. Answer required. That constants. Tell fast. So when you try, you can check correct or not. Anyway, correctly I am solving. Do you want answer? You are not replying. Do you want answer? Second condition, you go to recording now. No. Put x equal to 4, find theta c and yc. Go there. Put x equal to 6, find theta c and yc. What theta c you get here should be same theta c there. What yc you get here should be same yc there. That's all. No second condition. You have to arrange it. There is no second condition. Both two conditions will come. One, theta continuity. Second is y continuity. One is theta continuity. Second is y continuity. Only one tangent will be there. One is continuity of theta. Second one, continuity of y. Okay, try. I will tell the answer for you. Okay, try. How I give the answer, you don't bother. Your C1, tomorrow tell me the answer when I ask you, your C1 will come this side, minus 384. Your C3 will come minus 336. Your C1 will come minus 384, C2 will come minus 3. I'll check once again. Yes, 336. And remember, I am going to write something today. Remind me tomorrow. I will write here. I am going to write something here now. Let it be there tomorrow. I will tell you what is that one tomorrow. IA ayanantamanvi dmiyom yakstum. Okay. Okay, start. Now try. and get the answer. If you get the answer, tell me. That's all. Thank you. Tomorrow we'll meet. Board will be there. I will not rub anything. It will be as tomorrow continued from here. It will be continued from here tomorrow.